All right, so the review for the Chapter 7 test. Card is randomly chosen from a deck. What is the probability that it is a 7 or a 3? Now, with a 7 or a 3, there is no doubling up. The 7 is a 7 and the 3 is a 3. So it's two totally different numbers. Remember, anytime we see an or, we're going to be adding. So there are 4 7s out of 52. Okay, and there are 4 3s out of 52. So we're adding those together, and we're getting 8 out of 52, not 32, 52, which reduces to 2 out of 13. That's probably getting either one of those out of the deck. Now, number 2, what's probably getting a black or a 6? Well, you have to remember there are 2 black 6s. Yeah, there's a 6 of spades and a 6 of clubs. Since they're redundant, we're going to have to take those out, because when we do the black cards, which is 26 cards out of 52, and then we add the 6s, well, there's 4 of those out of 52, that's 30 cards. But we have to remember that 2 of them are redundant, because there are 2 black 6s and we'd be counting it twice. So when we do that, we end up with 28 out of 52, which reduces to 7 out of 13. Box of fruit contains 5 apples, 4 oranges, 2 bananas, 3 plums. So that's 9, 10, 11, 12, 13, 14. So we got 14 pieces of fruit total. If 2 pieces are chosen at random, what's the probability they will both be apples? Okay. Well, at first there's 14 pieces of fruit in there, and there's 5 apples. So the chance of grabbing an apple is 5 out of 14. If we're going immediately without replacement and grabbing a second fruit, well, now there's only 13 fruits left, and there's only 4 apples left. Therefore, we end up with, I'm sorry, I don't know why I wrote plus. Brain's a little wonky there. We're multiplying on these, which gives us 20 over 182, or 10 over 91. Now, if it would have said an apple followed by an orange, or an apple and a banana, then it would have been 5 over 14 times 4 over 13, or 2 over 13, or 3 over 13 for plums. But since it was another apple, we have to take 1 fruit out and also 1 apple out. That's why the second one's 4 out of 13. All right, there's 8 freshmen and 11 sophomores. Once again, that's 19 total. Good to have that number. If 5 students are selected at random, what's the probability of getting 2 freshmen and 3 sophomores? Okay, this is when we're going to use our calculator. You don't have to right now, but we're choosing, remember, 5 total students out of 19. Okay, so that's 19 combination 5 on the bottom. And then we just look at the 2 separate groups. We're choosing 2 freshmen out of 8, and we're choosing 3 sophomores out of 11. And you just enter that in the calculator. 8 math NCR, 8 math PRB NCR 2, 11 NCR 3. Multiply those and divide by 19 NCR 5. Okay? So when you type that in, you end up getting 0.397. So a little more than a third. If you convert it to a fraction, it is 385 over 969. Either answer would be acceptable. So again, a little more than a third. Number 5, in a class of 30 students, 19 have written an essay on history, 10 on politics, and 2 on both. So this is a Venn diagram problem, right? So we know we have 30 total. Okay. Putting history over here and politics over here. History, we know there's 19. Politics, we know there's 10. And we know there's an overlap of 2. So 10 minus 2 is 8. 19 minus 2 is 17. And if we add those up, we get 27, which leaves 3 in doing neither. So what is the probability a student has not written an essay at all? Well, that would be 3 out of the 30, or 1/10. 1 out of 10. Again, the more information you put down in your Venn diagram, the easier it becomes. Number 6. Probability on any day that your drain is clogged is 1 out of 15. The probability your faucet leaks is 3 out of 8. What's the probability that the sink will overflow on the same day? Okay, so because of both happening at the same time, so that's messed up. 1 out of 15 times 3 out of 8. You can type it in the calculator and get 3 over 120, or you can go, hey, wait, this goes into this 5 times, so that would just be simply 1 out of 40. Again, if you just did it, you would have gotten 3 over 120, which would have reduced to 1 over 40. But if you realize that 3 and 15 reduce by 3, simple math, you can do it all in your head. So a 1 out of 40 chance they'll both happen on the same day and the sink will overflow. All right, the odds in favor of winning. So remember, in favor, winning, so that's coming first, are 11 to 7. That means this is winning and this is losing. What's the probability of winning? So with probability, we need grand total on the bottom, which is 18. And the chance of winning are the first numbers, that's 11, 11 out of 18. A die is rolled 3 times in a row. What's the probability of coming up with a 4 each time? Well, that's 1 out of 6 the first time, and then 1 out of 6 the second time, 1 out of 6 the third time, which means the chance to get very slim. It's 1 out of 216. So each time you're expecting it to happen again, you're getting a smaller and smaller chance. A mixed pack of gum has 5 peppermint, 6 spearmint, and 9 bubble gum. So if you add those all together, that gives you a grand total of 20 pieces. If one is randomly selected, what's the probability that is peppermint or spearmint? Remember, that means we're going to plus them. So we're just going back to saying 5 out of 20 plus 6 out of 20, which is 11 out of 20. And since 11 is a prime number, there is no reducing that. Number 10. Same thing. Okay, these are still the 20 pieces. So is number 11. So we're dealing with 20 on all of those. Okay. But this one says if 2 are randomly selected, what's probably they're both peppermint or both spearmint. So we're trying to say both one or the other. Now remember, the or means we're going to be plussing, but we have 2 different NCR possibilities. Now either way, we're just choosing 2 pieces out of 20. 2 pieces out of 20. All right. We're also talking about 2 out of 5 and 2 out of 6. So that ends up being 1 over 14 plus, and that's for the peppermint, and 3 over 18, sorry, 38. And that's a 19, my bad. 1 over 19 and 3 over 38. Now, 1 over 19, when you get common denominator, that's the same thing as 2 out of 38. 19 times 2, so 1 times 2, which gives us 5 out of 38. So just to tie this in similarly, if we go back to the one we did on number 4, here we were trying to find 2 freshmen and 3 sophomores. So notice that situation is when we multiply those two. And the total on the bottom. Down here on number 20, we're looking at or, so we're just doing adding. All right, last one on this page. Same thing, 20 pieces of gum, okay? This one's a little bit different, okay? So you haven't seen this before, so I'm just showing it to you now. It says, same thing, 5 peppermints, experiment, 9 bubblegum pieces. If 3 are chosen randomly, what's the probability of getting 1 of each flavor? In this case, we're just trying to get 1 of each flavor. Then we're simply doing the 5 times the 6 times the 9, the representative numbers of each one. And on the bottom, remember we're choosing this time 3 out of 20. On these two, we were choosing 2 out of 20. This time we're choosing a third one. So it ends up being 5 times 6 times 9 over 20 NCR3, which ends up being 9 out of 38. That's our chance. Right. Number 10. 4 cards randomly picked from a deck. What's the probability all 4 are hearts? Okay. Well, there's 13 hearts out of 52. If the next card chosen comes out of 51, and there's only 12 hearts left. Next card chosen, there's only 50 cards left, and there's only 11 hearts left, theoretically. And last card is chosen from 49 remaining cards, and the 10 remaining hearts. When we multiply all of those and reduce this, which again the calculator will do for you, you get 11 over 4165. Now remember, you can just type in 13 times 12 times 11 times 10 divided by, you want to put it in parentheses, 52, 51, 50, 49. Or you can do alpha y equals and enter each one of them as a fraction. It's up to you. 10 6 and 1 half dozen of another. All right, if 4 are randomly chosen, what's the probability that all 4 are red? Well, similar idea, except this time there's 26 red cards out of 52. That's a 5. After that, there's 25 red cards left out of 51. 24 red cards left out of 50. And 23 red cards left out of 49. When you multiply those all out, we get 46 and reduce it, 46 over 833. Okay, number 14 is one where you have to pay attention to the instructions, the problem. It says probably your mother calls you. She's calling you is 6/7. Father calling you, is 2/7. What's the probability that neither calls you? If you go and do this problem right off the bat, 6/7 times 2/7, you will be wrong. 6/7 is her likelihood of calling you, which means she has a 1 out of 7 not calling. If he's 2 out of 7 calling you, he's 5 out of 7 not calling. So we need to do 1 over 7 times 5 over 7, because again, It's asking about neither calling. That ends up being 5 out of 49. So you've got to pay attention to the details in the question and not assume what it's asking. All right, number 15. Baseball team has won 16 games and lost 8. That is a grand total of 24 games. Why do I need the total? Because this is a probability problem, which means I need that denominator to be 24. What's the probability they will win? Then I need to look at this number, and that's 16 over 24, which reduces to 2 out of 3. Now notice this one is odds, and it says in favor, they will win. So that means win comes first. So that's 16 to 8, or reduced 2 to 1. So remember, probability is a fraction, and the bottom number is the total. Odds is a colon problem, and you have to look at what it's asking. So in favor, winning means winning, losing. Now, I will say, in case you do look at the answer key for this, there is a mistake. The answer key here has against. So if you look at the answer key in studying, just know that it is the same problem basically, it's just reversed. So it's 8 to 16, 1 to 2. Same answer basically, just in a different order. Not a big deal. I wanted to point that out. 17. A package is supposed to arrive tomorrow at your house. What's the probability it arrives between noon and 6 p.m.? Kind of a strange problem. I don't know. What is the probability? Well, you got to think about it. So we have our time period, and we have our total. Well, between noon and 6 p.m. is 6 hours out of a 24-hour day. So you're not given the answer, the number, but you kind of are. Now, if it would have said between 1 and 6, then we would have a 5 on top. 2 and 6, 4 on top. And then we reduce that to 1 out of 4. If it was 4 to 6, it'd be 2 over 24, 1 over 12. What's the probability that Labor Day falls on a day other than Monday? Whoopsie. 0. Because it's always on Monday. It is a Monday holiday. Now, again, the details. If it said, what's the probability Labor Day falls on Monday? Then it would have been 1. What's probability Thanksgiving falls on a Thursday? 1. What's probability Thanksgiving falls on a Sunday? 0. Okay? So make sure you're looking at the directions and the problem. All right. Smith makes 40% of the light switches at a factory. That's 0.4. While Jones makes the rest. That means 0.6. So 0.4 and 0.6. The factory inspector finds that 4.5%, remember that's 0.045 as a decimal, are defective. And 3%, remember that's going to be 0.03, of Joneses are defective. Based on this information, what's the percent of all switches should work? Okay, so in this case, we need to look at the numbers of the two different situations. Okay? So remember, if 4.5% fail, that means 95.5% work. So we have to always remember, if we're given one number, always look for the counter. And when we're talking about percent, we're always subtracting from 100. And 3%, the counter of that would be 97%, so 0.97. So we need those numbers because we're talking about the ones working, not broken. So these are the ones we need, which we got from the first numbers given in the problem. So again, sometimes you have to go beyond the given information and find what you need. So in this case, we're going to take the 0.955 times the 0.4, which is basically the Smith working ones. So again, Smith makes 40% and 4.5% fail. Therefore, 95.5% of the 40% should work. And we're going to add that to the 97% of the 60% that Jones makes. So this is the Jones working. So this ends up being 0.382 plus 0.582, which is 0.964, or 96.4%. About 96.5% of all the switches from both factories work. All right, now this one is a trickier one than the previous ones we did on the daily assignment for day 7. So there's an extra step here that makes it a little more complicated. And there's one like this on the test, so just pay close attention. So it says in the past election, 3.4%, again, that's going to be 0.0314, always good to make note of that, of the voters were mathematicians. So we have math people and 0.0314, which means these people are not math people. And that's 0.9686. That's the remaining out of the 100%. So there's our two groups, our two branches to start off with, math and not math. Of these being the mathematicians, 99%, 0.99, voted in favor of proposition pi, which means 0.01, 1%, were not in favor of pi. They want to kick. Of the other voters down here, 13% voted for pi, and that means 0.87 were not in favor of pi. Now, on day 7, all we did was, what is the probability of a math person voting for pi? And you would take this times this. Or a math person not voting for pi, and you would take this times this. Okay? That's the easy one-step answer. This is saying, what's the probability that someone who voted for pi is a mathematician? So this is a little bit more complicated. So we first got to find out who voted for pi here and who voted for pi here. So we're going to multiply like we have done, okay, like I just referenced. So this ends up being 0.031056, about 3%. This one ends up being 0.125918, about 12.5%. What we need to do is basically say, what's the total of people who voted for pi? because remember, our denominator on a probability problem is always the total. So that's going to be 0.157004. And then we're going to say, what about the mathematicians? 0.031056. And so if we take our calculator and do, I'll get it to work first, 0.031056 divided by 0.157. If you rounded this, no big deal. Now we get about 19.7%. And again, we hit math, fraction. And this is one of those ones that will not convert to the fraction. I'm just showing you that. So we end up with 0.1978, about 19.78%. So close to a 20% chance that someone voting for pi was a mathematician.